Okay, for this session, we're going to cover section 6.8, which deals with inverse trig functions and their derivatives. Mainly today, we're going to focus on the inverse trig part. So remember a few sections prior to this, we talked about inverses. And remember, an inverse means it has to satisfy two conditions. One is that it passes the vertical line test, and two, it passes the horizontal line test. So another way to describe that is that it's a function and it's also one-to-one. So if we look at this graph here, we have a sine graph, okay? Notice that it passes the vertical line test, so it is a function, all right? However, if we were to draw a horizontal line test, it does not pass, okay? So it fails as one-to-one. So in order to, again, satisfy the conditions of an inverse, it has to pass those two items, okay? Now, another component of the inverse is that to find the inverse of a graph, you just reflect it over y is equal to x. So if I were to draw a line going through the origin here, okay, and reflect it over y equals x, I'm going to get this graph here. All right. So what happens here is, again, in order to satisfy the conditions of an inverse, they had to restrict the domain of sine. So this is going from negative pi over 2 to positive pi over 2. Okay. Once they restricted the domain, then they're able to reflect this graph over y equals x, and you get the inverse sine function here on the right side. Okay. Right? And they did this for sine, cosine, tangent, and all the other trig functions. Okay? So it's important to understand that the background behind this, so in order for us to do these next set of problems. So for this section here, this is the formulas we're going to be using for this section. So I have already posted this in the resource folder in Canvas. All right, so let's go ahead and dive into some of the questions you're going to be dealing in this section. All right, so for this first one is they want us to find the exact value without using a calculator. Okay, so I'm going to pause this um, and see if you can figure out these two problems here on your own. Okay, so hopefully you had the chance to look at this problem and see uh, if you were able to figure it out. Okay, so how do we do this? Well, first of all, what we need to do is um, we need to rewrite this arcsine function. Okay, so this is they want us to find the exact value of this. So arcsine of negative radical 3 over 2. Another way to say that is inverse sine. Okay, so just different ways of saying the same thing. So arcsine and inverse sine are saying exactly the same thing. Okay. So again, what do we do? So what we're going to do here is we're going to let theta equal to arc sine of negative radical 3 over 2. Okay. Then we're going to um, take the sine on both sides because I want to get rid of the arc sine here. So I'm going to take sine on both sides. Okay. So then that becomes sine theta, and then this will cancel, and leaving us with negative radical 3 over 2. All right. So what we need to do here is we need to find sine theta, okay, negative radical 3 over 2 on our unit circle. So on this right side, as you look at this, you can find it in two areas, okay, at 5 pi over 3 and 4 pi over 3, right? So here is cosine and here's sine, right? Sine is um, negative radical 3 over 2 here at 5 pi over 3, and also here at 4 pi over 3. Okay, again, this is cosine, here's sine. Okay, so those are two spots that negative radical 3 over 2 is located. However, we are dealing with arcsine or inverses. So that means, again, as I mentioned before, we are restricted in our domain, okay, for the regular function, okay? And so that means we can only go from negative pi over 2 and positive pi over 2. So negative pi over 2 and positive pi over 2. Okay, so here's pi over 2 right here, right? So this is our positive pi over 2. If I were to go the other direction, okay, so um, clockwise. So counterclockwise gives us positive, and then clockwise will give us negative. So if I were to go the other direction, this would be negative pi over 2. Okay. All right. So so we want to use the location where it's between negative pi over 2 and pi over 2. So that's again at this location here. However, pi over 3 is not in the domain of sine or the range of the arc sine. Okay, so what do? Well, we need to find another way to represent 5 pi over 3. Okay, so notice if I were to go again counterclockwise, I hit 1, 2, 3 spots. Okay, so I'm from 11 pi over 6 to 7 pi over 4, and then 5 pi over 3. If I go this direction, I'm going to hit 3 spots. So that's going to be up pi over 6, pi over 4, and then pi over 3. Okay, so basically the distance between 0 and pi over 3, okay, is the same distance from 0 to 5 pi over 3. But in this case, we have to um, rewrite it where it will be between negative pi over 2 and negative pi over 2 and pi over 2. So in this case, this will be positive pi over 3, and going the other direction will be negative pi over 3. Okay, so negative pi over 3 will be in the range of the inverse function. So the answer to this question is going to be negative pi over 3. So again, we got 5 pi over 3, right? But again, we're outside of the domain of sine or the range of the inverse. So um, to find the exact location that's going to fall between that parameter, that will be at negative pi over 3. And the proper term of what I'm referring to is called coterminal. So 5 pi over 3 is coterminal to negative pi over 3. Reporting in. Okay, so let's look at the next problem here. All right, so this one we want the inverse sine of negative radical 2 over 2. Okay, so again, we're going to let theta equal the inverse sine of negative radical 2 over 2. We're going to take the sine on both sides. So we're going to have sine of theta, and then the sine and the inverse will cancel each other, giving us negative radical 2 over 2. Okay, so we need to go find that in our unit circle. So that's going to be at 7 pi over 4 and 5 pi over 4. Okay, so again, this is where sine is equal to negative radical 2 over 2. Okay, as well as here at 5 pi over 3. Sorry, 5 pi over 4. All right, so again, we are restricted, right? We can only be between negative pi over 2 and positive pi over 2. All right, so I can only be between here, right, at 90 degrees and negative 90 degrees. So negative pi over 2. Okay, so and again, 7 pi over 4 is outside of the range of the inverse, so we need to find a coterminal angle that's going to fall within negative pi over 2 and pi over 2. Okay, so if I were to you know, go 2 units down, so that's negative 11, I'm sorry, 11 pi over 6 and 7 pi over 4, and I go two locations up, I get to pi over 6 and pi over 4. Okay, so that means going counterclockwise, we get positive pi over 4, and then going counterclockwise, sorry, I mean clockwise, we're going to get negative pi over 4. Okay, so this value here falls within the range of the inverse. All right, so our answer, so again, we were at 7 pi over 4. We found the coterminal angle, which was negative pi over 4. So the answer here should be negative pi over 4. So that's our answer for that. Then again, negative pi over 3 was our answer for the first one. Okay, so I want you guys to try this next two here. So we have arcsecant of 2, and then we have inverse tangent of negative radical 3 over 3. So go ahead and take some time and see if you can figure these two problems out. Okay, hopefully you had an opportunity to try these two problems. So let's go through this. So arcsecant of 2. So what do we do there? Well, if you look in the formula sheet, it tells us that um, arcsecant or inverse secant of y is equal to the inverse cosine of 1 over y. Okay, so that's what we're going to be using here. So this is going to be the arcsecant of 2 is going to be the arc cosine of 1 over 2. Okay, and now we go through the same process as we did before. We're going to let theta equal to arc cosine, all right? Okay, so arc cosine of 1/2. We're going to take the cosine on both sides. So we'll have cosine theta, and then the arc cosine or the inverse cosine, and the cosine will cancel each other, leaving us with cosine theta is equal to 1/2. Okay, and then we look at your unit circle here to locate where cosine is equal to 1/2, and that's going to be at pi over 3, right? This is where cosine is equal to 1/2, and it's also going to be at 5 pi over 3. Okay, so cosine there is also equal to 1/2. Just like the inverse sine, we are restricted in the domain or the range of our inverse. So if we look at our formula sheet, it tells us that for our inverse cosine, we can be between negative pi over 2 and positive pi over 2. Okay. All right. So if we look at these values that we just located, right? Pi over 3 is going to be between negative pi over 2 and positive pi over 2. However, 5 pi over 3 is not going to be, that's going to be outside the range of the inverse. Okay, so even though it looks like it falls between negative pi over 2 and positive pi over 2, but the actual value of 5 pi over 3 is outside of negative pi over 2 and positive pi over 2. Okay, So our answer here is just going to be pi over 3. All right, let's look at the next one. So this one we have the inverse tangent of negative radical 3 over 3. All right. So again, let's go through the same process here of getting rid of the inverse tangent here. So we're going to let theta equal inverse tangent of negative radical 3 over 3. We're going to take the tangent on both sides. So that gives us tangent theta. And again, the tangent and the inverse will cancel, leaving us with negative radical 3 over 3. Okay. So where are these points located in the unit circle? Well, before we try to find out where that is, let's go ahead and rewrite what tangent theta is. So it's tangent theta, we can write that as sine theta over cosine theta. Okay. So if we look at a unit circle, okay, because we want to produce a negative radical 3 over 3. Okay, so if we look at a unit circle, negative radical 3 over 3 is going to be located at 11 pi over 6 and 5 pi over 6. All right, so how do we know that? Well, if we divide sine over cosine, so sine is negative 1/2 at 11 pi over 6, so negative 1/2, and cosine is radical 3 over 2. All right. So in this case, the twos are going to cancel, leaving us with negative 1 over radical 3. Well, in order to get rid of the radical and denominator, we just rationalize the denominator. That means we multiply the top and the bottom by radical 3. So that gives us a negative radical 3 over 3. Okay. So and if we do exactly the same thing for 5 pi over 6, we're going to get the exact same answer. Okay. But in this case, the negative's on the cosine instead of on the sine. But again, the output it will be the same, negative radical 3 over 3. Now, again, we're dealing with inverses, so we need to be careful in regards to the range that we're working in when we're talking about the inverse. So in this case, for the inverse tangent, that's going to be negative pi over 2 and positive pi over 2. So notice that the endpoints here, right, are not included. That's why it's parentheses instead of the bracket, like the inverse sine and inverse cosine. Okay. So again, 5 pi over 6 is out of the picture, right? Because that's way outside of our parameter. So, but again, 11 pi over 6 is also outside of the range of the inverse, but we can make it inside, right, by finding a coterminal to 11 pi over 6. So if we just go one angle up, that's pi over 6. So going the other direction, that's going to be negative pi over 6. So we have a positive pi over 6 going counterclockwise, and then negative pi over 6 going clockwise. So the answer to our question here is going to be negative pi over 6. Okay, so let's look at this next problem. We have cosine of inverse sine of 0.56. Okay, so again, go ahead and pause this video and see if you can figure this one out first. Okay, hopefully you had an opportunity to figure this problem out. Okay, so we will definitely need to use our formula sheet here to figure this out. So if you look at a formula sheet, it tells us that cosine of inverse sine, okay, of x is equal to uh, the square root of 1 minus x squared. Okay, so again, cosine of the inverse sine of x is equal to 1 minus x squared. So in this case, our x is going to be that 0.56 value. So if I were just to apply the formula here, this would just be the square root of 1 minus, okay, 0.56 square. Okay, and I just put that in the calculator. And when I do that, we get 0.8284. Okay, and it goes on 9, I believe it's 2601. Okay. All right. All right, so that's the answer to this question here. Okay, for this question, it wants us to express theta in terms of x using the inverse trig functions of inverse sine, inverse cosine, inverse tangent, and inverse secant. All right, so here they give us a right triangle, right? The box here on the bottom right corner indicates this is a right triangle. Okay, so if we have a right triangle, one way to find out what um, the side lengths are is just using the Pythagorean theorem, right? So if we have these two pieces of information, we can always find the third side of that triangle. So in this case, again, Pythagorean theorem is just a squared plus b squared equals c squared. So a squared plus b squared is equal to c squared. Okay, and then our goal here is to solve for c. So we can let a equal 6 and b equal x. So we'll have 6 squared plus x squared equals c squared. So that's 36 plus x squared equals c squared. And our goal is to solve for c. So that we just need to take the square root on both sides here. So we get c is equal to the square root of 36 plus x squared. Okay, so let's write that down here. So 36 plus the square root of 36 plus x squared. All right, now we just need to find what these ratios are. So remember in trig, right, we have the acronym SOHCAHTOA. Okay, so remember sine stands for opposite over hypotenuse, cosine stands for adjacent over hypotenuse, and tangent represents opposite over adjacent. So in this case, sine of theta, again, we want opposite over hypotenuse. So theta, I did not write that yet, but here it is. It's going to be here in the bottom left corner. Okay, so this is where theta is. So if theta is here, opposite of theta is going to be x, or in this case, b. Okay, so we'll have x over, and then the hypotenuse is 30 square root of 36 plus x squared. Okay, so that's our sine theta. Cosine theta is going to be adjacent over hypotenuse. So here's again, here's our tangent, here's our theta is right here. Okay, so adjacent to cosine is going to be 6. Okay, and then the hypotenuse again is square root of 36 plus x squared. All right, and then tangent theta is just opposite over adjacent. So here again, here's our theta. So opposite is going to be b over a, or x over 6. All right, so now we have all the information that we need. Now we can figure out what these inverses are. So to find the inverse of sine, we just take the inverse on both sides. Okay, so inverse sign here, inverse sign here. So we have theta is equal to the inverse sine of x over the square root of 36 plus x squared. Okay? And if I follow the same pattern for this one, again, we'll take inverse cosine on both sides. So this cancels. All right, so in this case, theta is going to equal to the inverse cosine of 6 over 36 plus x squared. All right, and then for the last one here, tangent theta is opposite over adjacent. So, um, so we have x over 6, right? And that is our problem, or that's our solution to that problem. X over 6 for tangent theta, but we do want the inverse of that. So we take the inverse on both sides. So the inverse tangent cancel, leaving us with the inverse tangent of x over 6. All right, so we have one more problem here, the inverse secant. So um, from our formula sheet again, it tells us the inverse secant, whatever is inside that argument or within that parentheses, the inverse cosine just flips it. Okay, so in this case, we need to start with the inverse cosine first. So inverse cosine of 6 over 36 plus x squared. All right, so the inverse secant is just going to be the opposite of this. So that would be 36 plus x squared over 6. And don't forget the square root here. Right? So those are answers. Okay, so why don't you guys try the next problem here and see if you can figure this out. Okay, so this problem here, I already figure out what b is, right? So b is going to equal the square root of x squared minus 81. So I just used, again, the Pythagorean theorem to figure that out. All right, so then sine of theta, again, I'm going to use the acronym SOHCAHTOA. So sine of theta is going to be opposite. There's our theta here. It's going to be opposite over adjacent. So that's going to be the square root of x squared minus 81. Right, so this is going to be opposite over hypotenuse. So this is going to be over x. Cosine theta is going to be adjacent over hypotenuse. So that's going to give us 9 over x. And then for tangent theta, that's going to be opposite over adjacent. So that's going to be the square root of x squared minus 81 over 9. Okay. Now we want the inverses of this, so we just take the inverse on both sides. So in this case, use a different marker here. So here we'll get the inverse sine of the square root of x squared minus 81 divided by x. Okay. Again, this is theta. Theta is equal to that. This one here, theta is going to equal to the inverse cosine of 9 over x, and this theta will be the inverse tangent of the square root of x squared minus 81 um, over 9. Okay, so we still need to find the inverse secant here. So we're going to use, this is similar to the last problem. So we have the inverse cosine of 9 over x. So the inverse secant is going to equal x over 9. So we just flip the 9 over x. Pause here for a second. Okay, let's look at another problem here. Go ahead and pause this video and see if you can figure this problem out. Okay, so the first thing we need to do is use Pythagorean theorem. Okay, so we're going to have a square plus b square equals c square. Okay, so an a in this case is going to be the bottom of this triangle. All right, so as you notice that, in regards to the big picture, we have a right triangle as well as the smaller triangle here is also a right triangle. Again, that's indicated by the small little box here on the bottom right corner. All right. So again, we can use Pythagorean theorem to start this off. So my a here will just be the bottom here, which is a, so that'll be a squared. My b is going to be the total length of this side. So 3 plus 2 is going to give us 5. So that'll be 5 square. And that's equal to c squared, which is in this case is x. So that's x squared. Okay. And we're going to solve for a. So we'll have a squared is equal to x squared. We're going to take 5 squared to the other side. All right. So we have x squared minus 5 squared. So let's simplify that a little bit. And we get x squared minus 25. Then take the square root on both sides. We get a is equal to the square root of x squared minus 25. All right, so we know that this bottom here is going to be the square root of x squared minus 25. Okay, all right. Now there's a lot of ways to solve this problem. Our goal is to find theta. Okay, so but again, there's a lot of ways to solve this. So you might get a different answer, and then that's okay because most likely it's the same answer as what I got, unless it's like totally way out there. Okay. All right. So let's go ahead and label um, the rest of these angles here on the bottom left corner. So let's say that let's label this big one here. Here's a different color here. All right, so that's this big one here. Let's label that theta 1. Okay, so theta 1. And then the um, bottom here, let's label that theta 2. Okay. All right, so for theta 1, we're going to have the tangent theta 1, right? Remember, tangent is just opposite over adjacent. So that's going to give us 5, right? So this is our opposite. So 5 over adjacent, which is going to be the square root of x squared minus 25. Okay. If we were to solve for theta 1, that's just going to give us theta 1 is equal to the inverse tangent of 5 over the square root of x squared minus 25. Okay. Now let's look at theta 2. So theta 2, we have another right triangle. So we can use SOHCAHTOA again. So theta 2 is just going to be opposite over adjacent. So that's going to be 2 over, again, same bottom here, x squared minus 25. Okay, so solve for theta 2, and we get the inverse tangent of 2 over the square root of x squared minus 25. Okay. All right. So now what we can do is we can just manipulate our angles here, okay, to find out what theta is. So notice for theta, okay, theta is just that just equals what? Theta 1 minus theta 2, right? Theta is just the big angle, the green one here, theta 1 minus a small angle, theta 2. And that will give us regular theta, okay? So in this case, theta 1 we found was the inverse tangent of 5 over the square root of x squared minus 25, okay? And then minus theta 2, that's going to be the inverse tangent of 2 over the square root of x squared minus 25. All right, so there is our answer for theta. All right, let's look at another problem here. So this one we want to find, again, the value without using a calculator. So this is the tangent of inverse tangent of 1 over 3. Okay, so again, go ahead and pause this video, see if you can figure this out. Okay, hopefully you had an opportunity to do this problem. All right, so if you look in the formula sheet, in the trig formula sheet, you'll notice that the closest thing that we have here is the tangent of 2 theta is equal to 2 tangent theta divided by 1 minus tangent square theta. Okay, you're like, how so? Okay, so in this case, okay, the inverse tangent of 1/3, okay, that is being represented as theta. Okay, so if we look at it, so tangent of 2 theta is the same thing down here as tangent of 2 theta. Okay, so again, the inverse tangent of 1/3 is being represented as theta. Okay, if that's true, if that's the case, then anytime we see tangent, we're just going to replace it with the inverse tangent of 1/3. So we'll have 2 times tangent of um, the inverse tangent of 1/3 divided by 1 minus tangent square of, in this case, what I want to do is I'm actually going to rewrite this. That's okay. So, so remember tangent square theta, I can rewrite that as tangent theta square. Okay. So knowing that, so let me write this part here. Okay. All right. So knowing that, then theta here is still going to be the inverse tangent of 1/3. Okay. But in this case, now we can square the whole thing. Okay, because of this, right? Because remember, theta is equal to the same thing as saying inverse tangent of 1/3. All right. So here the tangent, inverse tangent are going to cancel. Okay. And that leaves us with 1/3 and square. Okay, so that's going to give us 1 minus 1/9 on the bottom. And then the top there, the tangent and then the inverse tangent are going to cancel, leaving us with 2 times 1/3. So that's going to give us 2/3, and 1 minus 1/9 is going to be 8 over 9. So I just flip that. That gives us 9 over 8, okay, which is 18 over 24, which reduces to 3/4. Okay, so the last problem we're going to look at is this one. This one, the same thing, wants us to find the value without using a calculator. So we have cosine of the inverse cosine of 4/5 plus the inverse sine of 12 over 13. So again, go ahead and pause this video and see if you can figure this out. Okay, so for this one, the formula we're going to be using is the sum and difference formula here. So we have cosine of alpha plus minus beta is equal to cosine alpha cosine of beta minus positive sine alpha sine beta. So how you use this is in regards to the sign is, so if you have alpha plus beta, then you would use the top sign. If you had alpha minus beta, then you would use the bottom sign. So in this case, we have the top sign, so we're going to use the plus sign there. Sorry, the minus sign there. Right? So this is what we're going to be using for the middle. Okay, so how does this apply to what we have here? Well, in this case, the inverse cosine of 4/5, okay, that's going to be represented by alpha. So this thing here is going to be represented by alpha. And then the inverse sine of 12/13, that's going to be represented by beta. So wait, so alpha, and then this is beta. Okay. And then we're just going to follow this formula. So again, since we have a positive, right, we're going to use the top um, symbol there, okay, or the minus sign in this case. So here we're going to have cosine. What's alpha? Well, it's the inverse cosine of 4/5, okay, times that by cosine of beta, which is going to be the inverse sine of 12 over 13. And since we use plus, or that's going to correspond with the minus, so that's going to give us minus sine of alpha, which is inverse cosine of 4/5. Okay. Times that by sine beta, which is the inverse sine of 12/13. Okay. All right. If you look at your formula sheet, well, first of all, let's go ahead and see if we can cancel anything here. Okay, so the cosine and the inverse cosine will cancel, leaving us with 4/5 there. This one, we need to figure that out. Okay. And then these guys will cancel, leaving us with 12 over 13. Okay. All right, so we need to figure out these two. So cosine, inverse sine of 12 over 13. Okay, so if let me pause here for a second. Okay, so in the formula sheet, it tells us that cosine of inverse sine of x is equal to 1 minus x squared. So this here, okay, we're going to rewrite that as times the square root of 1 minus, and that would be our 12 or 13, right? Yeah. So we have cosine over times sine, so that will be our 12 over 13. That's going to be our x. So we have 12 over 13 square. Okay. All right. So then we have our minus in the middle. And then we need to find out the sine inverse cosine of 4/5. So I already have it here. Sine inverse cosine is equal to square root of 1 minus x squared. So we're going to have the square root of 1 minus 4/5. Okay, so 4/5 square. All right, and don't forget this is being multiplied by 12/13 here, which I already have. Okay. All right, so let's go ahead and simplify this. Well, 12 over 13, that's going to give us 144 over 169. So 1 minus that, that's going to give us 25 over 169. So we have 4/5 times the square root of 25 over 169. Okay, so remember for that one here, just multiply that 169 over 169. So 169 minus 144 give us that 25. Okay, and again, we still have the same denominator. All right, so for this one, we're going to have 1 over 16 over 25. Okay, so same thing, we're going to multiply this here by 25 over 25. So 25 minus 16 is going to give us 9. Okay, so that'll be 9 over 25. Of course, take the square root of that. Okay, and then multiply that by 12 over 13. Okay, and then don't forget the minus sign in the middle. Okay, so that's what we have here so far. So then we just simplify this. So we have 4/5 times the square root of 25 over 169. That's going to give us 5 over 13. And then this one is going to give us the square root of 9 over 25. It's going to give us 3 over 5. And then times that by 12/13. Okay. So we'll have 20 over 65 minus 36 over 65, which gives us minus 16 over 65. And that's our final answer.